This is the first video presentation for the CASE Agricultural Power and Technology course. As you view this video, be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Engineering Process, Lesson 1.1 Mechanical World. You have completed Activity 1.1.3 Efficient Design, during which you compared the efficiency of different tools. This presentation provides information about the engineering design process used in the agricultural power and technology industry. The scientific method involves asking a question, forming a hypothesis, and testing that hypothesis. The engineering design process is used to solve problems that are identified. It is a method to identify a problem, develop a solution for that problem, and test that solution. Similar to the scientific method, the engineering design process includes multiple, clearly defined steps. Each step will be explained by the next few slides. The first step in the process is to identify what the problem is. Examples in agriculture include soil erosion, cooling a barn for animals, or compaction of soil in a field from weight of a heavy tractor. Once a problem has been identified, research can be done to determine what is causing the problem and potential solutions for solving it. Understanding the causes, effects, and other background information for the problem helps to determine potential solutions. Criteria must be determined to prove if your solution actually solves the problem. Evaluating a potential solution according to a measurable target or goal is easier to accomplish. Other criterion may include maximum cost, efficiencies, or labor intensity. Engineers then brainstorm potential solutions they believe will solve the problem. The solutions many times involves a new product or machine. It may also be a new procedure or process. After developing a solution, a prototype should be built. A prototype is a sample or model that can be replicated. Materials, cost, and the procedure should be recorded so the construction process can be replicated and improved. The prototype is then tested to see if it meets the requirements to solve the problem. If it does not solve the problem, it will need to be redesigned and tested again. Another critical piece in the test and redesign step is to look for and correct errors. The basis for the final version of a prototype will be copied and mass-produced for people to use. Real-world use of the product will lead to new ideas on how it may be further improved. Communication is a vital part of the engineering process that encourages continual improvement of a product. Good communication will lead to the identification of new problems to be solved and requirements to be met. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to the previous knowledge. List any questions you may have about this topic. Discuss these questions with your instructor. Keep any notes that you have from this presentation organized and available to use throughout this course. Through Activity 1.1.4 Digging with Deer, you will identify how an entrepreneur and agricultural mechanics use the engineering process to improve the production of food, fiber, and fuel in order to understand how people in agricultural power and technology use the engineering design process to increase agricultural productivity and solve problems. Your teacher will provide more instruction for this activity.